All right, this is part 3 of 3 for lecture 1 of week 2. Up to now, we've introduced a few truth functional connectives in our symbolic language, SL. That was conjunction, disjunction, and negation. Today in this lesson, we're going to introduce two more, the material conditional and the biconditional. And before I say anything about what it corresponds to, we're just going to do the formal definition of it first, and then we're going to look at how it maps onto some fragments of English. So the material conditional is, in here I'm going to write it as a right arrow. So it's going from P to Q. Now in the book you have like a skinny sideways C, so it looks like this, where P is on this side and Q is on this side. So I guess I should do it your way. So P is here, and then Q is over here. Sorry, this is the right way to do it. If P, and then you have Q over on the other side. But here I'm just going to do an arrow, but this is just the same thing as what the textbook has in terms of what the symbol is supposed to mean. Okay, so the material conditional, here's how we're going to define it. When P is true and Q is true, then the whole material conditional will be true. When P is true and Q is false, then the whole sentence, the complex sentence, will be false. And whenever P is false, we're going to make the material conditional, so the whole sentence is going to come out true, and that applies in both cases where P is false. So as long as P is false, then the material conditional will come out true. So the whole sentence will come out true if P ends up being false. The only time when the conditional is false is when in the scenario where P is true and Q is false. And now let me also define the biconditional. Do it like this. And let me take these out. Okay. And the biconditional, I'll use this symbol. So this is a left and a right arrow. And in the text, this is represented as 3 bars. And the truth table for the biconditional, we're going to use looks like this. So when both P and Q are true, we're going to say that the biconditional is then true. If P is true but Q is false, we're going to say that the biconditional is false. When P is false and Q is true, then we're going to say the whole thing comes out false. And when both P and Q are false, we're going to say the whole thing comes out true. Excuse me. Okay, so these are our last two symbols that we're going to use, the last two connectives we're going to introduce in our language. So let's provide some examples for the material conditional. So I'm just going to put that underneath here. So the material conditional looks very much like if-then. And in fact, when we're going to speak about the material conditional informally, we're just going to read it as if P, then Q. So you can read the symbol that as if P, then Q. And actually, I should put this. Now, this is, again, as I said, this is one way we might say it in English, but the material conditional is able to express some things of English better than others. So let's look at a couple examples. So if you get 100% on all the quizzes, problem sets, and final exam, then you will pass the course. So we could represent this formally we might have, we'll say, so we'll let F stand for this first part, getting 100% on all quizzes, problem sets, and the final exam. We'll have our right arrow, the material conditional, and then we'll have C, which stands for passing the course. So F here is going to be the sentence, you getting 100% on all the quizzes, problem sets, and final exam. And C here is the sentence, you will pass the course. And the arrow, or the material condition, is specifying the relationship between these two sentences, namely that if F, so if you get 100% on all the quizzes, problem sets, and final exam, then C, you will pass the course. Notice here as well that this use of and isn't a sentential connective here. So if you don't quite know what I mean here, make sure to go back and look at the examples on conjunction in the previous video, where we talk a little bit about how and isn't always used as a logical connective, and I'm not using it as a logical connective here. So here's another example. If it rains outside, then the ground will be wet. So raining outside, so it rains outside is the first sentence, and the ground will be wet is the second sentence, and we've connected these together using the material conditional. So another way you can think about these is if you don't get 100% on everything, will you still end up passing the course? The thought is, yeah, you might get 99% on everything and still pass the course. So effectively what we just said there was this first part, which we call the antecedent. So we'll call F called the antecedent, and C we call the consequent. So if the antecedent is false, so up here we have the scenario where P ends up being false, so we're going to look at these two rows right here, then the whole conditional comes out true. So the whole sentence is true whenever the conditional is false. And so in our example, you can think about the scenario where you get 99% on everything. So it's not the case that you got 100% on all the quizzes, problem sets, and final exam. And nevertheless, you can still pass the course. So the whole, the truth value of the whole sentence is true even if the antecedent is false. Or in our second example, you can think of it here. So are there any scenarios in which if it's not raining outside, the ground can still be wet? Sure, if your friend is washing the car outside. So this whole sentence, this whole conditional in natural English, we take to be true if the antecedent is false. Now, I'm giving you these examples in natural language, but remember, logic isn't actually, we don't care too much about which sentences are in fact true and which ones are false. What we're trying to do is specify a logical relationship that holds between these two atomic sentences. And the material conditional, as we've defined it, seems to be able to capture some cases of English, like the ones I gave you. But in class, I'll go over a few examples where you can see where that comes apart. So the formal truth functional connective, the material conditional, isn't always able to express things in English. And yeah, so we'll leave it at that for the material conditional. So a nice way of remembering this truth table here is that the only time the whole sentence is false, whenever the material conditional comes out false, is when the antecedent is true and the consequent is false. So if you want a bit of an intuitive grasp at first, think about the scenario where you get 100% on everything and you fail the course. Then is this sentence true? So if you get 100% on all the quizzes, problem sets, and final exam, then you'll pass the course. Intuitively, this sentence is false in that scenario. And similarly here. So you have the conditional sentence, if it rains outside, the ground will be wet. How can you make this sentence come out false? Well, you think of a scenario where it's raining outside, but the ground is not wet. Now you might not, that might be a hard instance to imagine, but the point is the sentence will be false in that scenario where it's raining, but the ground is not wet. Okay, and lastly we have the biconditional. And you can read the biconditional in English in the following way. So we have P right left arrow Q. And you can read this as P if and only if Q. So hopefully you'll remember that I gave an abbreviation in class once where, or maybe even in a lecture where I said that I sometimes will write if and IFF to mean if and only if. So here we can read the biconditional in the same way, if and only if. But importantly, this is not necessarily the English version of if and only if. It will express similar sentences, but maybe not all of them. And we'll go over some examples in the discussion of where the limitations come up. And so you can think about it like, let's go over a few examples. So John will go to the party if and only if Susie does. So the idea here is this sentence, when is it true? Well, it's true when both John goes to the party and Susie goes to the party. And it's false if one of them does but not the other, right? So if Susie doesn't go to the party and John does, and somebody says, look, John will go to the party if and only if Susie does, that person said something false, right? So the sentence that they expressed ends up being false. The one odd example, or one odd place you might think of, is when both of them end up being false, right? So when both components of the biconditional are false, the whole sentence will still come out true. And intuitively you can think, well, if neither John went to the party nor Susie went to the party, then this sentence is still true, right? John will go to the party if and only if Susie does. So if Susie doesn't go to the party, John better not go to the party either. And as long as that's the case, then this sentence will still come out true. Okay, so that covers the truth functional connectives for symbolic logic. If you have any questions or comments, please feel free to add them, and we'll see you soon.